Hi everyone, so this is going to be for assignment 2. So just recording an after class tutorial on some of the things we looked at. So we're going to start by looking at NURBS meshes and sub-Ds, the differences between them. We're going to look at Blender topology and then export settings from Blender to Rhino and then Rhino fabrication workflows. So let's get started. So the first thing we will do is let's go ahead and create a few geometries. So let's say, for example, let's pick something like a torus. Just going to start building something. We're going to set radii. Let's just go with, let's say, 12. And then let's go with maybe, yeah, we're just going to go with arbitrary numbers right now. So that's a solid tool. So this is basically a NURBS geometry. So if you look up here, it says one closed surface. I'm going to create a sub-D torus. Same thing, 12, and then we're just going to go out and try to make it the same. So we've got sub-D here, NURBS here, and then let's go ahead and make a mesh torus, 12, and then somewhat similar in thickness, just so we can compare. All right, so let's put NURBS, mesh, and sub-D. That's how it's. So again, we have NURBS, so one closed surface, as you can see up here. This is a closed mesh, as you can see up here, sub-D up here. So one trick of looking at sub-D is you can press tab and it'll show you sort of the non-subdivided version. So press tab again, and then it'll show you the subdivided version. So let's start by looking at some of the differences. So for NURBS, let's go, it's a closed surface. If we go explode, nothing happens. It says cannot explode single surfaces. It's a single surface right now. We're just going to turn on ghosted mode so you can kind of see what's going on inside. For meshes, if we go explode, again, a mesh could not be exploded into multiple parts. And then sub-D, if we go explode, again, there's nothing that can be done to any of these just because they're all sort of in their most basic form at the moment. So why don't we go and see what kind of manipulations are possible. So press Control and Shift at the same time and press a cell. So you can see how I've just sort of selected a face here. And if I was to extrude this out or move it, it just sort of moves out this way. And then let's do the same thing to sub-D. If we were to move this out, it kind of moves along the same lines as the mesh, just a bit more of a refined version. It does that. And then let's see what happens to the NURB. Press Shift and Control. Nothing. You cannot select any of it because it's just one single surface, and that's how it's constructed. Okay, so let's try something else here. So if I was to select the mesh geometry and I go to sub-D, I'm just going to use, let's just say I'm going to use the same default settings that are here. Right click, and then it gives you a sub-D. So let's select the sub-D. Let's move it out. And you can see how it's very similar to the geometry that we have on the right side. So that's kind of interesting. Okay, anyways, we'll delete this sub-D. It's shown us kind of what to do. Let's go back to the sub-D. Let's see if we were to take this sub-D and go to mesh or just mesh. Press enter. We're just going to use all the default settings, go all the way down in level, press OK. Let's see what this gives us. So close mesh. So this did not come out to be similar to the mesh. So we couldn't reverse engineer it. In fact, it gave us a bit more of a subdivision level in terms of the mesh. So anyways, it kind of goes, and shows you what's possible, or what the differences are between some of these things. Let's go ahead and make another sub-D torus. I'm just going to make it right here. Just out of curiosity, I just want to try something. So we have this sub-D. We go to NURBS, sub-D options. I'm just going to pick faces unpacked. Use the setting, and then let's take the poly surface. So this time, if you can see here, turning the sub-D into a NURB gave us a closed poly surface, which is interesting. So it's not just a single surface. So if you select this torus, it's a closed surface. This one is a closed poly surface. Let's see if we were to go back to sub-D and go to NURBS, sub-D options, faces unpacked, or faces packed, I guess, this time. Right click, and now it's given us a geometry surface. Now you can see it's a surface when I selected faces packed, which is interesting. So faces unpacked gives us a closed poly surface, and if I go explode this, it gives us 60 surfaces. So all of these little cells can be selected. Let's just go back to shaded view so you can see. Yeah, all of these can be selected. But if I was to go to the single surface, closed surface that was created from sub-D, and I go explode, nothing happens. Cannot explode single surfaces. So it's just a single surface. So just some of the distinctions to understand when going from sub-D to NURBS, which is how you'll be bringing geometry, especially when you need to use NURBS from Blender to Rhino. Okay, let's move some of these geometries aside. I don't want to get too confused. One of the neat things I wanted to show you here is how you can extract geometry from NURBS. So, for example, let's say if I want to go ahead and start, creating sort of a wireframe structure or an armature to make this torus, let's say, I can go on here and I can go extract isocurve. Okay, now you can see how it's giving me an option. And if I go here, I can select direction, U or V. So U is one direction and V is perpendicular to that, but I'm going to go both. And then ignore trims. No, I'm just going to leave that as default. And then I'm going to right click. That did not work. So let's try it again. Right click, direction both. Right click, it didn't do anything. Try one more time, right click. This time I want to select extract all up here. See my mouse. Extract all. And then right click. This time I think it gave me my curves. Yes. So if I was to move this donut away, this torus away, you can see how I've been left behind with my armature geometry. So I could actually take this, I could build out this armature, I could create more jigs and build out this wire armature, cover it with some kind of material, and I could be able to make this torus if I wanted. Okay, so that was just a sort of a video showing, some of the distinctions between sub-D meshes and NURBS, and how to get NURBS from sub-D. And just for fun, we'll go back to this mesh. We're just going to go to sub-D, right click, leave the default settings, and then I am going to move the mesh out of the way. And again, you can see how it's very similar to the sub-D that we had originally, that we had just simply manipulated. And something fun, if you want to start, really getting into sub-Ds, you can click on this and you can type crease. Mesh of sub-D edges and vertices to crease. Okay, let's say if I want to select these vertices or these edges here. Right click, see what that does. Quite interesting. It does similar operations to things that happen in Blender. But you can really start to, model things. Oh, it looks like a genie lamp. Anyways, yeah, you can really start to model things the way, things are also done in Blender. But anyways, it's not the perfect tool for sub-D modeling. So let's move on to Blender. And I'm just going to go through some of these pavilions and topology. So let's just start new. Let's go Shift A. We're going to make a mesh plane. Make sure the size is 10 meters. Just a good size to work with. Let's zoom into it by pressing the period button on your number pad. Okay, let's go into edit mode, loop cut. Let's put a loop cut this way and another one this way. And that's it. Let's go back into object mode. Let's make a copy of this along the y-axis. So press Y, move it down. So let's work with this one here. So let's go edit mode. So tab for edit mode, bevel. We're just going to pick the outside corners. Okay, we're going to bevel it. Just bevel the edges. Okay, and then we're going to take the second object. And actually, we're not going to bevel this at all. So let's just go back to the first object here, the first plane. Let's go into vertices. Let's pick the middle vertices of the long edges and then the center point, pretty much. And we're going to move this up. Let's move it up by, let's say, 7 meters. It doesn't really matter. Let's just go with 7. So just enter 7 and it'll take it there for you. And then this one here, second one, we're going to go with, let's go to object, edit mode, select some of these vertices. Then we're going to move it up, type 7, just so we have apples to apples comparison. So the main difference between these two is that I have not added a bevel to the outside corners. Okay, so let's just see what the difference is between the two. So we're going to make a copy. So Shift D, move over in the x-axis, just move it over. And then I'm going to take the first one, add a modifier, subdivision surface, Cardinal Clark, and we're going to go with levels 2. Let's turn off optimal display because I actually want to see my wireframe. Okay, so you can see kind of what's going on here. Let's make another copy on the x-plane, and then the difference I'm going to do here is under boundary smooth, I'm going to say keep corners. Okay, I just want these corners here. Okay, and then so let's go to this object. Before we move on, I'm going to make a copy again of these two objects. Let's go in the Y direction. And so this one was levels viewport 2 and 2. So these two, I'm going to make them 3 and 3. Okay, so here, one of the things you'll notice is that there is a bit of symmetry in the topology, but that's kind of what we see here in the Blender workspace. So let's just see how that symmetry works when we take it into Rhino. But before we do that, let's also take this object. Let's add a modifier, subdivision surface, levels 2, turn off optimal display so we can actually see our mesh lines. And then let's make a copy in the X direction. And then, so this one here, we're going to say boundary smooth, keep corners. And then let's make a copy. Actually, no, we don't need to make a copy for this one. I'm going to let you guys work that out on your own. But let's just see. Let's take these objects into Rhino. So export, FBX. I'm going to go select objects. Blender to Rhino. 02. So give it some kind of nomenclature that works for you. And then we're going to go Z up because that's how Rhino also works. And we're going to leave everything as is. So export FBX. So let's go into Rhino. We're going to go File, Import, then do Rhino 02. And I'm not going to go through the whole cycle of bringing them in as meshes, but I want to bring them in as sub-D so I can convert them nicely to NURBS and work with them. So I'm going to go open import meshes as sub-D surfaces. Let's press OK, and I'm going to let it scale. And this is sort of how it brought in. And it overlaps them. I'm not sure why, but that's just how it is. So, okay, this actually puts us in a bit of a disadvantage because now we need to see how our planes are working. Let's just try to organize it the way it was. Okay, so this one kept my corners, and this looks like level 2 subdivision. So I'm going to bring this. This goes here. This goes here. This goes here. This goes here. Well, this goes here. Anyway, organize it the way you like. Kind of got it like this. Okay, so let's just try to understand what's happening with the topology here. So if I was to look at this, if I was to do further manipulations on this, right? So as a sub-D object, this is not something really, Grasshopper is not going to be super friendly with this. So I need to convert some of this geometry. So what I'm going to do is I'm going to take this sub-D object. In fact, I'm going to take all of these. I'm just going to go to NURBS. Okay, I'm going to go delete input no, because I still want to be able to compare faces packed. And then let's right click. Delete objects no, and then yeah, just this. We take our older objects are moved. But anyways, I have a selection filter up here. So if you guys don't have this, just type selection filter. Okay, I just deleted mine, so I'm going to bring it back, selection filter. And you should see something like this, and you can dock it. So just drag it and dock it where you want. Now I have overlapping geometries here, sub-D polysurface. So I want my polysurfaces and my surfaces only. So I'll press shift. So press down shift, keep it pressed, and click polysurfaces, then click surfaces. And then I'm going to select all of this, move it over. So my sub-Ds have remained because I did not select them. So you can use a selection filter to, when you have overlapping geometries, you can select things. So anyways, let's have a bit of a comparison. So I've got these two geometries here. As you can see, when I wanted to keep corners, it did keep it. It rounded the corners a little bit, but it did keep it for the most part. So let's compare. So these here are level 3 subdivision in the viewport, whereas these are level 2 subdivision. So let's understand the topology. So I'm just going to take these NURBS and I'm going to go explode. Okay, so it divides the objects up. Now, if you look at level 3 subdivision, when I click on this and this, you can see how it sort of spans from left to right. It's not really giving me a symmetry to work with in terms of topology as to how the computer is constructing it. But level 2 subdivision gives me a middle plane, and it gives me these objects or these sort of surfaces along the sides. So I could have some symmetry here. So I could go join this. I could join this. I could join this. And I could join this. And now I have these surrounding surfaces that are symmetrical. It's much better to work with in terms of computation and parametricism. There are uses for, this type of geometry as well, but it's not really something we're touching on. We're going to stick to the fundamentals and work with something that's more grasshopper friendly. So just to show you, what's possible with geometries like this, whether or not you keep corners like this one here or not, is I have a model over here that I've got enabled with Grasshopper, which we'll be giving you an introduction on. You can see how it starts to create this pavilion type geometry, which I think is pretty cool. So really, it becomes computation friendly, and you can see how things are flowing from one surface to the other. So that's for bringing geometry in and playing with it. And let's say now, I want to take one of these geometries, let's say this one here, and I want to fabricate it. Okay, so first of all, like, you're not going to be able to do this with sub D. You have to convert it to NURBS. Actually, let's go first to mesh because I want some level of planarization. I want some planarized meshes, so I'm going to go mesh, keep the least amount of sub-D meshing parameters, press OK. Let's see what that gives us. So my sub-D has been dragged to the right side, and then here's a mesh. Then just to get a bit of a comparison, I'm also going to bring my NURBS mesh down here. And you've got these open surfaces. So this isn't really something that's fully developable. Right? Like, it's got these curvatures to it, but maybe it's possible. Before we do that, why don't we do a curvature analysis? So this is a tool I actually wanted to show you guys. Let's just type curvature analysis, selecting objects. So I'm going to select this one, right click, and then it shows you here. It shows you if it's sort of within this range here, within this green range, means it's not bad in terms of curvature. Like, it's not fully red, it's not fully blue, it's somewhat in the middle. Ideally, you want it to be completely green, so things are flat. But in this case, it might be something that's developable. So anyways, that's one way to look at curvatures. If you want more information on this, just go on the McNeil documentation and see how this works and actually use it in your low poly fabrication projects. So anyways, I'm going to go out of this. Let's have a look at curvature analysis on this. Now here, you can see how the curvature is a bit crazy. So it's more towards the red. So red meaning it's more curved in the upwards direction. If it was curved in the lower direction, it would be blue. Yeah, so that's kind of how it works. Let's just see if it's going to do that for me right now. Copy this over and just rotate it. And just do a curvature analysis. Yeah, doesn't really make a difference at this point. Okay, and just keep, trying these things so you understand how the tools work and in what context. So again, this is an open mesh. Curvature analysis will not work on mesh, so you can see how it's more NURBS friendly, not really so much mesh friendly. Anyway, so we've got this open mesh here. And let's say I now want to go ahead and fabricate from this open mesh because it's got more of these quads here. So there's a few things that you can do. So let's select this open mesh. We're going to go to NURBS. Let's just make the NURBS, polysurface. And here now you can see how it's starting to subdivide it a bit more. Okay, so it's getting a little bit dense. Now I want to try something else. Two NURBS. Trim triangular faces, no. Just want to see what that does. Okay, it didn't make a huge difference in our case. So let's go back to this poly surface. Let's do a mesh, a curvature analysis. And you can see how things are mostly in the yellow range, means they're somewhat curved. They're not exactly flat. So you can really play with this. You can go auto range. So 0 is green in this. Okay, so 0 is green. So those areas are flat. And then the blues are not so flat. So I know for a fact that these blues will need adjusting because I might have trouble making them because they're not flat. So what we could do here is actually let's keep loaded and then select all of it. And now I want to see if my curvature analysis still works. It works. Okay, so now let's go ahead and select these blue faces because I know that they will be troublesome, and you can extend it out. And this is something that's really, this is a hidden trial. There's no formula. This is something you have to try out. You even have to try fabricating it to see if it's working or not. Okay, and I'm going to go triangulate mesh. There's also this command called triangulate non-planar chords, which is interesting. I've not tried that. But anyways, let's go triangulate mesh. We triangulate it, select meshes. Okay, that is not working. So let's go back and let's go triangulate non-planar chords. That didn't do anything either. Oh, what am I doing? This is a NURB. So, okay. So the triangulate is not going to work on NURBS, right? So one of the things now you could do here is you could delete this. You could go in here and you could select surface from 3 or 4 corner points. And now you could select your corner points. Make sure you're snapping good. You've got one triangle, done. And then you could go here, make another triangle, done. And now this should be flat. So let's check it out. So we go curvature analysis, and now you can see it's perfectly flat because now I've got 2 triangles, and triangles are always planar in terms of fabrication. So that's one method. Okay, now let's move on to another method that I want to try. So this was an open mesh. I'm just going to make a copy of the mesh. And you can see how this mesh is not exactly like giving me quads. So there are methods that you can use in Grasshopper to, flatten your quads, but we're not there yet. We're going to first see how this works in Rhino. So let's just go triangulate. Triangulate mesh. So triangulate mesh triangulates the entire mesh. Okay, and then if I make a copy and I go triangulate non-planar quads, which is interesting. Triangulate quad if out of plane by distance, angle, both, increment. You can even select quad, split method, shortest diagonal. This is really something good to play with. So if I go triangulate, you can see how this is, it's quite interesting the way it's given me the triangulations. And you can, I think there's ways to manipulate this if you want, but it seems like all the quads were I guess curved. So it went ahead and triangulated all of them. So we're going to try something else. So instead of bringing geometry in as sub D, as surface, and then converting them to NURBS, what we're actually going to do is for this exercise, we're going to go back here and we're going to bring just these two geometries in export. Let's just say we'll bring it in as obj. We do r02.obj. And everything else is the same. Selection only. I only want to bring in what I'm selecting. Export wavefront obj. Okay, so now let's go back to Rhino. We will import. This time we want our obj file. And I'm going to leave everything the way it is. Okay, and then here's my objects. Let's just manipulate these and see what happens. So you see how it's a bit more, I guess, pixelated in a manner of speaking. So let's first do a bit of conversion process. So if we were to go, I'm just going to make a copy of these, and I'm going to say triangulate non-planar chords. Okay, it seems like it still wants to do all of them, because all of them have a bit of an angle or curvature. This one is the same thing. But if I go triangulate non-planar chords, triangulate chord out of plane by a certain distance here. See, so it gives you a live view of certain chords that can be somewhat flat, but are getting triangulated. So let's just see how this works. So we triangulate this, and now it's giving us some triangulation. So to do a bit of a comparison, I'm going to take this original mesh, and I'm going to say two NURBS. Delete input options, no. Mesh options, trim triangular faces, no. I'm just going to say, go ahead. I just want to select my poly surfaces and surfaces. So I'm going to bring this over here. So now this is an open poly surface, right? So it's a collection of surfaces. So the other one, it's a collection of surfaces. And yeah, that's the one I want right now because I want poly surfaces. So let's go ahead and do a curvature analysis and the order range. So yeah, we're just going to stick to order range that works with the geometry at hand. So here, now you can see 0 being green, which is the flattest. These blue ones are the ones that have a bit of a curvature. So when I gave the triangulation a bit of a tolerance that, okay, I don't want everything triangulated, but here's a little tiny bit of tolerance. So the ones that have some curvature, let's do those. The ones that are minimal curvature or like totally flat, I don't want to triangulate those. So you can see how it picked the blue ones on the left side to triangulate on the right side. Okay. So this is good. So there's a bit of a comparison here, but I could only run the curvature analysis on the NURBS. So let's go back and we've got this open poly surface. Now let's say I want to fabricate this. Okay, let's just make a copy. Always keep your original geometries. In fact, let's go ahead and say, let's try to convert this to NURBS. The one that we triangulated a bit, not completely triangulated. Let's see what it gives us. Yeah, so you can see how it's developing, it's triangulated surfaces. So it's a poly surface. I'm going to make a copy of this poly surface. I'm going to explode it. And now you can start to understand how you will construct it. So you could go all the way from here. This could be one strip. Let's join it and then let's give it a color. You could have a strip that's like this. Let's join it. You could give it a color, and then you can do the same thing here. So now you have repeatable parts. See, that's the advantage of bringing in a topology that works support to support. It's got symmetry. Now you can build like parts. This is red, and then again, this is green. This is red. Let's keep joining it as we're going. I don't think I joined all of them. So green, and so on and so forth. And then the middle can be its own thing. Now, I won't do all of it for you, but I'll show you one as to how we would, fabricate it. So let's take these aside. And just keep in mind that this has to be, this is only going to work with surfaces and poly surfaces. This doesn't, unroll does not work with meshes in Rhino. So let's select this one and this one, and let's go unroll, surf. Explode, no, because if you explode it, then it'll turn it into small pieces. Labels, yes. Key properties, no. Relative tolerance, warning, etc., etc. Let's just go unroll and see if it did anything. No objects are selected. Uh-huh. Okay, so it didn't work when I selected the green and the red together, but it worked when I did them separately. So it unrolls always at the origin. So let's bring this over here. And then we will unroll the green one. Lord, no. Labels, yes. And then here it is. We'll bring this over. So now let's say if I want to create a flap between my red and green geometries. Okay, so let's find the corresponding edges. So 22 for this green one corresponds to 22 here and 7 here, 0 and 20. So I need to rotate this like so. We'll bring it close to this guy just so I know, somewhat how things go together. But these are flat patterns. You can now export them. You can make 2D them. So let's just kind of go through that. So top, let's show you very quickly. You can select this, make 2D. Then you go view, top, you can select tangent edges. That just gives you sort of, some of your edges there. And then let's just, you play with some of these settings. And then we're just going to go okay right now. And let's see what it gave us. So it actually gave us all the dots again. And then you can see how your edges are all here. Now it's line work. Right? So you can take all of this and you can go file, print, and then you need to find the settings to make sure that it prints to scale. You can also export these to Illustrator and then print from there. Anyways, I'll leave the print settings to you guys. Let's go back to these geometries. So select them. And I'm just going to right click on this zoom selected button. So it zooms in on them. I don't keep scrolling in weird places. But you see how it's given you all your bend lines and all of this information. So let's say I want to have a flap between number 2 and this edge here and this edge, number 9 edge here. So, and I want it to be the same thing. So let's just go into top view. And let's just start making an edge. Just give it a bit of an angle here. And then I'll just go mirror. Then you just find the perpendicular. And you mirror it. And then you join it. And there, you have a nice symmetrical flap that you can use to glue things together. If you've done craft lessons, this should be pretty easy to do. So rotate this, and now I just rotated it, and I want this to correspond to this. And I'm going to go rotate again, pick the one spot that you snapped it, and then just pivot it. There you go. Now you have a flap. Of course, my measurements here are arbitrary, so please make sure that your flap will have, sufficient surface area for you to glue things. So that's one way for you guys to be able to do it. So these are pretty easy examples. So for assignment 2, you're not gluing your pavilion. If you want to practice, it's a good one to practice with, but just follow the assignment handout to go through this process. So there you have it. Rhino fabrication workflows to make little low poly paper models. Thank you.